Number 11 from this New Higher Specimen Paper 1. There's a graph here and it says explain why the function f of x. Now notice this isn't the graph of f of x, this is the graph of the rate of change of f of x. Explain why the function f of x is never decreasing. Well, this graph shows the values of f dashed x, the values of the rate of change. And despite the fact that that might look as if it's going down and up, all these are positive values. All the values along this graph are positive, apart from this one, where it's 0. But it's certainly never negative. So I can make this statement. F dashed of x is greater than or equal to 0. Which means you could say f dashed of x is never negative. Which means that the values itself, f of x, is never decreasing. I don't actually like what they put in the marking scheme because this just talks about the value of a function. The marking scheme seems to want you to put in gradient equals to. And of course gradients refer to the graph of the function. But this just says the function itself is never decreasing. That's purely numerical. Will the values of this function ever go down as you increase x? No. Why? Because the rate of change is never negative. So it's either 0 or heading up. Now part B says, on a graph of y equals f of x, the y coordinate of the stationary point, because it does equal 0 once, is negative. Sketch a possible graph. Now it doesn't ask for any reasons, so I'm just going through this again. There is a value when f dashed x is 0, and that's here. So I know that that's a stationary point. What's the nature of that stationary point? Well, f dashed x, if you like, goes in the order of, for the various x's, it goes, whoops, even though these numbers are getting smaller, they're still all positive. Then it's 0, and then they're still positive, only getting bigger, which means it looks like this. The stationary point is a rising point of inflection. I should have put an x there. And if it says the y coordinate is negative, it just means that that rising point of inflection is going to be below the x-axis. Remember, just because f dashed x is always positive, it doesn't stop the actual values from being negative. You can have negative values that keep increasing upwards and so on. So just put it anywhere below like that, for instance. But it's always heading up. This graph's always heading upwards, so it's going to head up, take a wee turn, and then carrying on heading up. So the 2 marks would be, first of all, for putting this stationary point somewhere in this 4th quadrant, because it'd have to be in line with that, but down below because it's negative. And having a point of inflection on a rising graph. In other words, a rising point of inflection.